All right, so now in this example here, we're going to do an example with numbers, and then we're going to do one with a variable with the n, right? So the nth term. So now in the number case, one of the things we can do with factorials is because we've got division and multiplication, that's all we're using, we can cancel things out, right? So if we use the 8, we can always decompose the 8 factorial like follows. 8 times 7 times 6 times 5 factorial, right? So we could break it apart and still keep the factorial because all we're doing is we're breaking off the 8 times 7 times 6, right? And then on the bottom we have 3 factorial times 5 factorial. Well, because this is just multiplication and this is multiplication, these are the same. This is the same product, right? 5 factorial is the same as 5 factorial, and since it's multiplication over division, we can just cancel these out, okay? And so then we can simplify this as 8 times 7 times 6 over what? 3 times 2 times 1. Well, 3 times 2 is 6, which cancels with this 6, which then gives us 56. So 8 factorial divided by 3 factorial divided by 5 factorial is 56. Now what if we're given an expression like this where we don't have numbers but we have two expressions? We can still solve this, right, by doing a similar thing, right? So we have n factorial and we can decompose the bottom as what? N plus 1 factorial, or excuse me, 2. N plus 2 factorial. What's the next one below that? N plus 1 factorial. Or excuse me, not factorial. I'm sorry, I keep saying factorial. N plus 2 times n plus 1. And then what's after that? N. And we can stop there and we can just write n factorial. So n plus 2 factorial is the same as n plus 2 times the quantity n plus 1 times n factorial. And again, because we have the same thing on the top and the bottom here, and it's multiplication, we can cancel those out, and we get 1 over n plus 2 times n plus 1 as our final answer. All right. Have a great day.